Hello everyone. In this lesson, I'll solve the ministerial question of lesson 4.2, second derivative test, uh, in the book of the ministerial question, page number 140. Action number 1, find point of inflection for f of x equal 5x power 3 minus 15x. Find f prime of x equal to 15x power 2 minus 15. Then the second derivative, f double prime of x will be 30x. Set it equal 0, then x equal 0 is a critical point. Find the sign of the second derivative before and after 0. Before 0, take negative 1. Negative 1 times 30, it is negative. After 0, take positive 1, then the sign is positive. Therefore, 0, 0, substitute 0 in the function, f of 0 equal to 0 minus 0 equals 0. Then 0, 0 is an inflection point for this function. Question number 2, find an inflection point of this function. The first derivative equal to 4x plus 3 to the power 3. Then the second derivative, f double prime of x, will be 12x plus 3 to the power 2. Set it equals 0. Divide both sides by 12 and take the square root of both sides. Then x plus 3 equals 0. Then x equals negative 3. Find the sign of the function before and after negative, of the sign of the second derivative before and after negative 3. Before negative 3, take negative 4, then negative 4 plus 3, negative 1, power 2, 1, times 12, positive. After negative 3, take 0, 0 plus 3, 3 power 2, positive, times 12, positive. Then the function is always concave and there is no point of inflection. Choice D, none. Question number 3, find the inflection point of the function f of x equal to x plus 4 power 2 times x minus 2. You can use the rule of derivative of multiplication of two functions, or you can open the bracket as you like. Let us open this bracket. F of x equal to x power 2 plus 8x plus 16 times x minus 2, then x power 3 minus 2x power 2 plus 8x power 2 minus 16x plus 16x minus 32. This is the function. Simplify it. X power 3 minus 2x power 2 plus 8x power 2 plus 6x power 2, negative 16 with positive 16 minus 32. Then f prime of x, the first derivative, is 3x power 2 plus 12x, and the second derivative, f double prime of x, will be 6x plus 12. Set it x equals 0. Factorize by 6, x plus 2 equals 0. Divide both sides by 6, then x equal negative 2. It is a critical point. Find the sign of the second derivative before and after negative 2. This is the second derivative. Before negative 2, take negative 3. 6 times negative 3, negative 18 plus 12, negative 6. Negative 1 times 6, negative 6 plus 12, it is positive value. Then negative 2 is an inflection point. Choice B. Question number 4. Find the inflection point of this function over 0 pi. f prime of x equal to the derivative of sine x is cosine x, derivative of cosine x negative sine x. The second derivative, if w prime of x equal to derivative of cosine negative sine x minus cosine x, set it equals 0, then sine x equal to negative cosine x. Then sine x over cosine x equal negative 1. That is mean that tan x equal negative 1. Then x equal tan inverse 1 equal to pi over 4. Tan is negative in quarter 2 and quarter 4. In quarter 2, since here the sign is positive, cosine negative, and here is cosine positive and sine is negative. In quarter 2, x equal to pi minus pi over 4 equal to 4 pi minus pi, 3 pi over 2, over 4, sorry. In quarter 4, x equal to 2 pi minus pi over 4 equal to 7 pi over 4. This point not belong to the interval 0 pi, open interval, but this point belong to interval 0 pi because it is between 0 and pi. Then 3 pi over 4 is the inflection point of this point, and the right choice is 3 pi over 4, 0. Question number 5, find point of inflection of f of x equals sine x over 2 over interval 0, 4, 5. The first derivative, f prime of x equal to 1 over 2 cosine x over 2. Then the second derivative will be negative 1 over 4 sine x over 2. Set it equals 0. Divide by negative 1 over 4. Then sine x over 2 equal 0. Set x equal to equal to zeros of sine n pi, where n is integer. Then x equal to 2 n pi. Then x equal to, when n is 0, x is 0. When n is 1, then x equal 2 pi. When n is 2, then x equal 4 pi. But 0 and 4 pi, it is not in the interval. Then only the possible inflection point is x equal to pi. Then the right choice is C. Question number 6. Find point of inflection of this function f prime of x equal to 3x power 2 minus 12x plus 12. Then the second derivative, f w prime of x equal to 6x minus 12. Set it equals 0. Factorize by x. X minus 2 equals 0. Then x equal 2. Substitute 2 in the function to find the y coordinate. 2 times 3, 8, minus 6 times 4, plus 24, 12 times 2. 8 minus 24 plus 24 equal 8. Then 2, 8 is the inflection point. Choice C. Question number 7. Find the inflection point of the function f of x equal to x power 3 minus 5x. F prime of x equal to 6x power 2 minus 5. Then if double prime of x equal to 12x, set it equals 0, then x equals 0 is the inflection point of this function. Choice B. Question number 8. Find the inflection point of this function. Rewrite f of x as x power 2 over x plus 1 over x equal to x plus 1 over x. It is easy to find the first and second derivative. F prime of x equal to 1 minus 1 over x power 2. Then the second derivative, f double prime of x equal to 2 over x power 3. Set it equal 0. Then 2 equal 0, cross multiplication, contradiction, there is no value, make the second derivative 0. But the second derivative is undefined at 0, and 0 is not in the domain of the function, then there is no inflection point for this function. The right choice is D. Question number 9. Find point of inflection for f of x equal x square root x plus 5. F prime of x equal to the first function times the derivative of the second, 1 over 2 square root x plus 5, plus the second times the derivative of the first, square root x plus 5 times 1, the derivative of x. Then the first derivative will be x over 2 square root x plus 5 plus square root x plus 5. Simplify this derivative, the common denominator 2 square root x plus 5, x plus 2 square root x plus 5 times square root x plus 5, 2x plus 5 equal to x plus 2x plus 10 over 2 square root x plus 5 equal to 3x plus 10 over 2 square root x plus 5. Find the second derivative of this function, f double prime of x equal to denominator 2 square root x plus 5 times the derivative of the numerator 3 minus the numerator 3x plus 10 times the derivative of the denominator 2 over 2 square root x plus 5 over denominator square 4x plus 5 equal to 6. 3 times 2, 6 square root x plus 5. Reduce 2 with 2 minus 3x plus 10 over square root x plus 5 over 4 times x plus 5 equal to common denominator square root x plus 5 times square root x plus 5, 6 times x plus 5 minus 3x minus 10 over 4 times x plus 5 equal to 6x minus 3x, 3x, 30 minus 10, 20 over square root x plus 5 times x plus 5, x plus 5 to the power 3 over 2. Set it equals 0, cross multiplication, then 3x plus 20 equals 0, 3x equal negative 20, x equal to negative 20 over 3, not in the domain of the function since it is greater than 5, and the denominator is from, since it is less than negative 5, and the domain is from negative 5 to positive infinity. The right choice is none. Question number 10. At which interval the graph of the function f of x equal x to the power 2 over 3 is concave? The first derivative, f prime of x equal to 2 over 3x to the power negative 1 over 3. Then the second derivative, f double prime of x equal to negative 1 over 3 times 2 over 3 negative 2 over 9 x to the power negative 4 over 3 equal to negative 2 over 9 cube root of x power 3. Set it equal 0. Then negative 2 equals 0. Contradiction. There is no value. Make the second derivative 0. But the second derivative is undefined at 0, and 0 is within the domain of this function. Therefore, x equals 0 is possible inflection point. Let us check the sign of the second derivative before and after 0. Before 0, take negative 1, negative 1, power 4, 1, cube root 1, 1, negative 2 over positive value, negative value. After 0, take 1, cube root x to the power 4, 1 to the power 4, 1, cube root 1, 1, then also the function is negative. Therefore, x equals 0 is not an inflection point. The right choice is D. Question number 11. At which interval the graph of the function f of x equals sine x minus x is concave over an interval 0 to pi? The first derivative, f prime of x equal to the derivative of sine x is cosine x, derivative of x is negative 1. Then f double prime of x equal to negative sine x minus 0. Set it equal 0. Then sine x equal 0. Then x equal to n pi. Then x equal to, when x is 0, 0. When n is 0, x equals 0. When n is 1, x equal pi. When n is 2, x equal to pi. Therefore, let us check the sign of the second derivative in the interval 0 to 2 pi, and here the pi. Therefore, the possible and only possible inflection point is at x equal pi, because pi is between 0 and 2 pi, and the sign of the second derivative before pi, this is the sign, the graph of sine, this is pi. Before sine, the graph is positive, positive times negative, it is negative. After pi, the sign is negative, negative times negative is positive. Therefore, x equal pi is an inflection point. Choice C. Question number 12. Find the point of inflection of f of x equal to x ln x, f prime of x equal to the first function times the derivative of the second plus the second function ln x times the derivative of the first. Reduce x with x, then 2 plus 2 ln x is the first derivative. The second derivative, f double prime of x equal to derivative of 2 is 0 and derivative of ln x is 1 over x, then it is 2 over x. Set it equal 0, then 2 equal x, 2 equals 0, contradiction, there is no value, make the second derivative 0. But the second derivative is undefined and 0 is not in the domain of the function, because the domain of this function is from 0 to positive infinity open interval. Therefore, there is no inflection point for this function. Question number 13. The inflection point of f of x equal x plus cosine x over 0 pi is which of the following points? The first derivative f prime of x equal 1 minus sine x. And the second derivative f double prime of x equal to negative cosine x. Set it equals 0, then cosine x equals 0. Then x equal pi over 2 plus n pi the zeros of cosine where n is integer number. When x equals 0, then when n equals 0, then x equals pi over 2. When n equals 1, then x equals 3 pi over 2 is out of the interval because 3 pi over 2 is greater than pi. Therefore, the only possible inflection point is x equal pi over 2. Choice B. If we substitute pi over 2 in the function, we find pi over 2 plus cosine pi over 2. Cosine pi over 2 is 0, then pi over 2 is an inflection point for this function. Find point inflection of f of x equal e to the 2x minus 2x power 2 plus 1. The first derivative equal to 2e to the 2x minus 4x. And the second derivative, f double prime of x, equal to 4 e to the 2x minus 4. Set it equals 0, factorize by 4, e to the 2x minus 1 equal 0. Then divide both sides by 4, e to the 2x minus 1 equals 0, e to the 2x equal 1. Take the ln for both sides, ln e to the 2x, ln 1 is 0, then x equal 0 is the inflection point of this point of this function. Substitute 0 in the function to find the y coordinate. E to the 0, 1 minus 0 plus 1 equal 2. Therefore, the right choice is B. Question number 15. Find the inflection point of the function f of x equal 5 over 3 minus x. The first derivative equal to the denominator times the derivative of the numerator 0 minus the numerator times the derivative of the denominator negative 1 over 3 minus x squared equal to 5 over 3 minus x all squared. The second derivative f double prime of x equal to the denominator times the derivative of the numerator 0 minus the numerator times the derivative of the denominator 2 times 3 minus x times negative 1 over 3 minus x power 4. Reduce 3 minus x with 3 minus x power 4. Negative 1 times negative 5. 5 times 2, 10 over 3 minus x to the power 3. Set it equals 0. Then 10 equals 0. Contradiction. There is no point make the derivative 0. The second derivative is not defined at 3, but 3 is not in the domain of the function. Therefore, there is no inflection point. Question number 16. Let a less than 0 negative value. The graph of f of x is concave on which of the following interval? The first derivative, f prime of x equal to 3ax power 2 plus 6x plus 4. The second derivative, f double prime of x equal to 6ax plus 6 equal, set it equals 0, factorize by 6, ax plus 1 equals 0, divide both sides by 6, then ax plus 1 equals 0, then ax equal negative 1, then x equal negative 1 over a is a critical point. Find the sign of the second derivative before and after negative 1 over a. Before negative 1 over a is negative, then negative over negative is positive value, then you can take 0. 0 is less than any positive value. Substitute 0 in the second derivative, 6 a times 0, 0 plus 6, it is positive value. Take a value greater than negative 1 over a. Take value greater than negative 1 over a. Take negative 2 over a. 6a times negative 2 over a, negative 12 plus 6, negative value. Therefore, the interval of concavity is from negative infinity to negative 1 over a open interval, choice A. See you next lesson.